So today we're going to start by talking about a scatter plot, which is just a graph that relates two different sets of data by displaying them as ordered pairs. So like all the graphs that have like these little dots on them, like this and this and this, those are called scatter plots because there's dots scattered all around them. Sometimes they're also called histograms, just so you know. And we're going to make scatter plots, and then we're going to draw trend lines through them with our rulers, okay, today. So there are three different types of correlations, okay? So if it appears as though all the data, so if this first one is going in a trend that is moving upward, you would say this is a positive correlation. If it is, the data is kind of like all going in the same directions but heading down, this would be a negative correlation. And sometimes the data will be scattered everywhere and it's not really going in any direction. This would mean there is no correlation. So correlation, this is important for a lot of real world stuff. This is how we figure out, for example, that like smoking cigarettes is linked to cancer. They take data like from patients and then they see if there is a correlation there between there. That's what we're talking about. And so sometimes people get these ideas, right? And they're like, I wonder if these are linked. And the data ends up looking like this, where it's kind of all over the place. And so then they cannot link them. There's really no correlation. It just seems like it. And so maybe there's something else that would link the two. And so we use this scatter plots in math, in science, in business, like in the real world all the time. So today we're going to start by making the scatter plot. So if it asks you to make a scatter plot of data, what you got to do is take a look at all your information. So on this first one, it's talking about the plane altitude and the outside temperature. So what do you guys know about temperature versus the altitude? What do you know about it, Donovan? That's right. Okay. So like airplanes have to know that stuff. If it gets too cold in an area, their engines can freeze up. Super important. You don't want that to happen. Then you crash and die, right? Also, in a less kind of, if you're flying lower, if you're going to jump out of the airplane, right? You got to know that too, right? You're going to go up in a shorts and a t-shirt and then it's 0 degrees when you jump out of that airplane and the wind is hitting you. That's going to be a problem, right? Yeah, it's not going to be good. Okay, so what we're going to do is we're going to start, and this is going to take some time because we're going to start, we have to graph all this data. So the most important parts in making your graph, number one, you need to label your independent and dependent variables. So the top is always going to be on your x-axis. That's independent. So down here is going to be our altitude. And that's measured in meters. And you always want to put, oh, hold on. We're not on screen. Sorry. Online people. All right, there we go. So across the x-axis is altitude. And you want to put what it's measured in. So it's measured in meters. And then this is always going to be our dependent variable, is our y. And that's going to go, that's always second. We're going to label this temperature. And the temperature here is measured in degrees Fahrenheit. Then based upon your data, you need to decide on a scale, okay? So like your altitude, your lowest altitude is 0 and your highest altitude is 5,000. So going by ones is not going to be ideal. What do you want to go by? 500. By 500. Let's see if it will work. If I start at 0 here, 500, 1,000. So then if I skip 2,000, 3,000, 4,000, 5,000, is that going to be enough? Yeah. Yes. Okay. So start at 0, and you can label every one. You can also skip like this, right? And realize that this would be 500, this would be 1500. It depends on how much room you have. You want people to be able to read it is important. So you don't want to jam data in or jam numbers in if you can help it, because the whole point of having a scatter plot or a graph is for someone to be able to read it. All right, now let's talk about temperature. So temperature, our highest temperature on there, if you look at the data, is not the first one, it's third in, 61.3 degrees. And then what's our lowest? 0.6. So we got to get somewhere between 0 and 62. And we've only got, so this has got to be 0, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spaces. We could go up another one. What do we want to go by? So we can go to get to 60, 10, 20, 30, 40, 50, 60. That would be enough. It would kind of jam our data in. Could we go by 5s? Yeah. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So we would have to go up in here. But it would probably give us a better picture, all right? So let's go by 5s. Again, I'm only going to label every other one, knowing that 5s are in between. And then you will have to kind of make your graph go a little bit higher here and label up here because we know we're just above that in one of our data points. So this would be 60. And then the part that is going to take a little time is now you have to estimate and plot each of the points. So at altitude of 0, the temperature is 59 degrees. So you want to estimate where that point is. So go ahead, put all your dots on. And then, and yeah, you're going to have to estimate because some of them are really close. For example, 59.2 is mighty close to 59. And so, and the first 3, you're hovering kind of in the same area. And then once you get to 1500, we start dropping a little bit. And so you want to put them on. So 2000 is 41.6. And because of the space, it's going to be really close. 2500 is 29.8. 3000 is 29.9. So those are super close. 3500, 18.1. 4000 would be 26.2. 4500 is 12.4. And then our last data, 5,000 is at 0.6, really close. So you're hovering at 0 degrees Fahrenheit there once you're at 5,000 feet in the air. Okay, and so that's important knowledge for pilots, for engineers of airplanes. So they have to put in safety features on airplanes so they don't freeze. So this is a scatter plot of the data. The only other thing that is missing, the other thing that a scatter plot needs is a title, okay? So you need to label your independent and dependent variables. So maybe we ought to write that in, that this is your dependent always. Dependent, because this is our notes. And this is called independent. And then the title is usually, if the data is given to you already in a table, here's the title, plane altitude and outside temperature. Woo. If it's not given to you, you can title it whatever you want. It just has to kind of go with what you're talking about, okay? And so you usually write the title at the top, but I didn't leave a lot of space. So we'll write it here, plane altitude and outside temp. So if you're getting graded on making one of these, you're getting graded on writing in, on multiple things, not just your data points. You're getting graded on, did you label your independent and dependent variable? Do you have a scale that is modeling your data in a good way? Like going by ones makes no sense here. Do you have a title? And then are all your data points in the right spot? Okay, so now the question is, and this is where like they're going to make some important decisions on this, and I'm going to show you with a trend line on the next one, but part B says, what type of relationship does this scatter plot show? Go, Elsie. A negative correlation is correct. This is a negative correlation. It is showing that as your altitude increases, what happens to your temperature? That's right. So a negative correlation says as our altitude increases, the temperature decreases. Now, why do you think it's not like in this nice straight line? Why do you think that it's a scatter plot where it's like scattered around? Emma, go. Wind, pockets of air. In the real world, it's not everything is perfectly linear, but it makes a linear trend, which is what we're going to show on the next part. So you can make pretty good estimates, but there's always these like outliers, right? So around the ground level, heat might be rising up off of, if they're on tarmac, especially for an airplane, right? Tarmac is black and it has a lot of heat, and you can feel it for quite a while. And then, okay, now they're getting up higher, right? At 2,000 feet up, they're not feeling any of the Earth's heat anymore, or as much. And so now we're really starting to get away from that. Okay, so that's the first part. Are there questions on the first thing we had to learn today? And that's just making the scatter plot. Cool, good. Okay, flip the page. All right, so the next page is where we're going to talk about trend lines, also known as line of best fit, depending on what question you are reading or what material you're reading out of. So a trend line or a line of best fit is why we're going to use a straight edge today, okay? So it's a line that you draw through the best of your ability through the middle of the points, right? So the idea is, and it's going to show a correlation. So the idea is you want to have as many points above the line as there are below the line, right? And a lot of times they will be really close. Now, there are two words that go with it. Interpolation is when you make that line and you are going to predict some sort of value between 2 points that you already know. That's on the graph that you make. Extrapolation is predicting a value outside the range of your data. So, like if your data only goes, so on our airplane data before, it only went to 5,000. But we could draw a bigger graph and draw a line out from it and predict what we think the temperature would be at 6,000 outside of the data that was collected. That's extrapolation. All right, so I'm going to read this while you guys are finishing writing it down. If you are online right now, you can pause the video and write those definitions. Okay, so this is writing an equation for the trend line so that we can then make predictions. So this right here already did this for you, but it says make a scatter plot of the data at the right. What is the approximate weight of a 7-month-old panda? So if you take a look, I copied the scatter plot. It's already made, but here would be the table that we would be looking at. So the weight of the panda, or the age of the panda, I'm sorry, versus the weight. So at 1 month old, the panda is 2.5 pounds, 2 months, 7.6, all the way to 12 months, which is a year, they are 54.9 pounds, okay? And the data is graphed here. So, the reason we do this now is to make predictions, right? So 7 months old is not shown on this table, right? They didn't maybe measure then or whatever. But there is a way that you can use then, if you've done this, you can predict it, right? 7 months would be right here. And then you would follow that up to your line, right? And so this would land on the line right here. And then you follow that over to here. And you make a prediction based on the weight. So what number is directly in between 24 pounds and 36 pounds? 30. So this line right here underneath there is 30, right? 30 pounds. And our line goes a little bit above that. So what's a good prediction for 7 months old? 31. About 31 pounds. Okay, would this be interpolation or extrapolation? This is interpolation because it was in the data that we talked about. So this is interpolation. Now, this is not on there, but I am going to add it, okay? How could we then use this trend line to figure out, for example, what if we wanted to know 20 months? Okay, assuming that the panda continues to gain weight, let's say, for the first 3 years of its life. What? Yeah, well, so let's assume that, though. So a 20-month-old panda is not in this data. So your choice is to either extend the graph out, draw the line, or you can write the equation for the line you drew. Okay, so here's our line of best fit, right? So let's pick 2 of these pieces of information, right? That look like they're right on the line. So according to this, does it look like 4 is right on the line? Yeah. What's another one that looks like it's pretty much really close to right on the line?
8.
Yeah, also the 8 one. Oops. So 4 and 17.1 and 8 and 37.9. We can assign this. This can be x1, y1. This can be x2, y2. How would we find the slope? Or the rate? Go, Emma.
37.9 minus 17.1 over 8.4.
Yep. Okay, and so this is going to give us our rate or our slope that the panda is gaining weight. So 37.9 minus 17.1, who's got that? What's the answer to that? 37.9, what is it? 20.8 over 4, right? So it's saying 20.8 is our weight, that's pounds, in 4 months. So if we divide that, what do we get? 5.2. Okay, so, I'm sorry, I lost my space here, but, okay, so 20.8 divided by 4, 20.8 pounds in 4 months is really 5.2 pounds per month, right? Think about, now, we have to figure out our Y-intercept, because is the baby panda, when it's born, is it 0 pounds? No, it's not, is it? So, now, if I take a piece of data here, and I put it in. Now, this is where it gets a little bit weird, but let's take one of our points, right? We're going to use y equal mx plus b. We're going to put 5.2 in for m, and we're going to use one of these. I'm going to choose 4 and 17.1. So times 4 equals 17.1 plus b. All right, well, what is 5.2 times 4? 20.8. Okay, so if I subtract 20.8 from both sides, I do get a negative number, don't I? So he's not going to be a negative poundage at birth. That does not work. However, it will help us predict by using that spot. It's still going to help us predict the weight that he is later, because what that's saying is that the gaining of weight in utero while it is in the mom's belly is a different rate that it is once he's born. Okay, so what do you get? 17.1 minus 20.8. What do we get? Negative 3.7. Thank you. All right, so our equation is y equals 5.2x minus 3.7. What do I put in to figure out how much he weighs after 20 months?
You put 20 for x.
That's right. So I would do y equals 5.2 times 20 minus 3.7, and it would predict for me how much he's going to weigh at 20 months old.
Oh.
Yeah, nice. Okay, so what do we got? 5.2 times 20 minus 3.7. How big is this beast going to get? 100.3 pounds at 20 months, okay? And this is what really happens in the real world. Humans, we don't love surprises, right? And we want to predict what's going to happen. Well, we use these trend lines and we write the linear equation if we can figure out that it's kind of linear, and we can make some pretty good predictions about what's going to happen, right? So same thing with people who get like these little tiny dogs and don't do any research, and then after a year, the dog is 100 pounds, right? Okay, huge. Well, if you had done the research, people have figured that out by now, right? And so that's what we use the trend lines for. Okay. If you're online right now, you can email me with questions, and I will get back to you as soon as possible. Today, the assignment will be to do 5-7 practice, numbers 1 through 6 only.